Okay, so the first thing, let's see. Uh, okay, we last time we still get the problem with the more IC you need to know. Okay, so now we continue on that. Let's see, I don't know, remember which one.
I think you were going over the 7th segment.
Let's see, that one we done or not done. 244 and 7, did it last time, right?
The 244, the 541,
Okay,
and the 7th segment.
okay, 244. If you get a question, just bring it up. Make sure you understand how the IC working. Okay, and basically this is a 7 segment. They will be converting from BCD to the decimal. Okay, the thing is that is to uh, interface to the human. The thing is human deal with the decimal, not binary. Okay, let's see what else. Okay, this is the 139. That we're using a lot. Make sure you must be understand it. That's what we call a decoder or the multiplexer. You get two IC. One will be 139 and another one will be 138. We'll see how they work it. Now, on this IC 139 here, if you're looking into here, they will be get 16 pins, okay? 1 up to 16. 16 will be power 5 volt. Pin number 8 will be round, okay? And try to see how many input for this IC. Can who tell me how many input for this IC?
2.
Or
Huh. That try to say who can tell me correctly how many input for this IC.
4.
Aha.
There's 2 for each well, the whole IC have 2 parts in it, isn't it?
Two different. But I asking about
The
how
lower
many
one, right?
input.
A and B.
You can
6.
tell by the pin number, okay? I want to know
6.
how many inputs.
6 input, right?
Perfect. 6 input.
Oh.
because we're counting the
Okay.
enables as well.
Pin 1. Enable for this guy. Pin 15. Enable for the second one. And pin 1, on the first one, you can get input A1, B1. On the next one, you can get input A2, B2. So the total will be 1, 2, 3, 4, 5, 6 inputs. How many output?
8.
8.
8. You get it now. You can say 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now try to see how they're working. They don't have a true table for this guy.
Mr.
139.
Pham, Mr. Pham,
Yeah.
since you have the output pins labeled as data outputs, would it be fair to say that there are 4 data inputs, but 6 inputs total?
6 input.
But only 4 are data inputs, is that correct?
Yeah, A1, A2. I'm talking general about input to the IC.
Right.
Okay. So
Okay.
basically they get A1, B1. They controlled by input pin 1. Okay. That means you get 3 input. And
Right.
same thing on the other side. You get A2, B2, and they control by 15. That's another 3 input. And the output will be 4. Okay, for each. Now, if you're looking here, okay, first thing, if G mean enable, either enable for this guy or this guy. What happened? When enable at the logic 1, then the input select A1, B1, A2, B2. We don't care. Okay? And they get the 4 output, on of the output must be 1. That happened the same thing for either A1, B1 or A2, B2. For example, if pin number 1 at a logic 1, then doesn't matter A1, B1 to be. Output must be on high. Same thing happened for the second here. If pin 15 at a logical 1, and they don't care B2, A2, output must be on high. So that's why here, Y0, Y1, Y2, Y3, all high. Okay? Now, if the enable at a logic 0, I'm talking about this one first. You understand this one, you understand the other one. So, for pin 1 is 0. Now, pin A and B here, if the 0, 0. So if you're looking at the true table, the first one will be low and the rest will be high. So basically they're working this way. This is the true table for select for the select AB. 0, 0, the first low. 0, 1, the second low. High and low, the next low. High and high, the last low. That's only telling you the output here, they only low 1 at a time. Okay? They cannot be low both. Only output Y0, Y1, Y2, Y3. If Y0 low, then the rest have to be high. That happened the same thing for the second one. That's what they call decoder. So anything about this recorder. Make sure if you get pin 1 high, then no matter what A1, B1 equal, output on must be high. That's how the 74 139 working. And now see the next will be 138. What the difference here? 138. Okay. They don't have an IC in here, right? Correct. They're giving you the truth table. Now, On this 138, the difference between 139. 138, they get a select A, B, C. That means they get 3 input. And if you get a truth table for 3 input, you get a 8 combination. Okay? And output here, you get 1, 2, 3, 4, 5, 6, 7, 8. 8 output. Now, if the enable at a logic high, then they don't care ABC. All of the output must be 1. Okay? That's an enable. However, if you get a right connection in here for enable, then you can see 3 input low, the first Y0 low, the red will be high. Okay? And you get next combination 0, 0, 1, and the second low, and the red will be high. And you see that one go down here. They're telling you the output of 74, 138, you can get only 1 low, and the red have to be high, depending on the combination A, B, C. Okay? If
Quick question, Mr. Pham.
just a minute. If enable, do not enable, no matter what ABC, all output must be high. Okay, go ahead.
Because 138 has 3 data inputs where 139 only has 2, do they have the same number of pins?
They get the same number of pins, correct? 16
Okay.
pins.
Okay.
Okay, so this one is they try to using 139. The thing is you can using separately. Okay, separate for 2 decoder. On this one, you can get 1 IC, but you're able to control 8 output at the, with the 3 input ABC. This one is separately, you can using A1, B1, control 4, and another A2, B2, control 4 separately, but they did not, okay? They combine, but they're working identical. Output only 1 low. You understand this using a lot inside your computer. The thing in your computer, when you get a memory, not 1 IC, they get more IC memory with the same data, the same input, output, but only 1 memory can be enabled. So that's why they must be using the decoder to control. Okay, when you go to the memory, you can understand a little more. Now,
Mr.
what
Pham.
I see,
Mr. Pham,
Mr.
Yeah.
Fan,
can you go back to, can you tell me why is it that we got those little bubble on the data output?
that means when they active low, that means when you select it, they will be go low.
They're active low, but why is it active low?
Why active low? That
Because
means
when you have when enables low and you have data going in, then everything's high, and except for 1 pin that's low,
okay, now, if pin 1 is 0,
right?
enable, okay?
Mm-hmm.
Depend on A, B, A1, B1.
Right.
If you get 0, 0,
Mm-hmm.
so the first one will be low,
Right.
and the rest will be high.
Right.
That's why they put active low. That means they active, they low,
Okay.
okay?
Yeah.
So if you change here, and the next one will be low, but the rest will be high.
Okay.
Okay, you understand it. I see you understand the next one, 138. They're working identical.
Right. Right.
Okay?
Mr. Pham,
Yeah.
I don't understand what the select is doing. Could you explain the ABC select, please, again?
ABC here, right?
Yes, sir. I don't understand the function of that select.
Okay, that means they allow the output here. Which one will be low?
Okay.
By apply to a input ABC. I given you example. If I apply A0, B0, C0, when I'm looking at the output, Y0 will be low.
Okay. Got it. Got it. Got it.
Okay, the red must be high.
Yeah.
Oh.
And the main difference between 131, 139 is in the 131 only one output can be low, right?
Now the same thing, the same way.
Okay, so what is the main difference between the 38 and 39?
Okay, the difference between you can using only 2 pin. Only one part of this IC here for output. However, for this IC 138, you get an output will be 8 output.
Okay, okay, got
Okay.
it. Okay, got it. Thank you.
Okay, now the next one, 164. 8-bit serial in, parallel out. Okay, now you understand the data transfer from one place to the other. They must be serial. You understand you transfer data from point A to point B. If you're using the serial, you can transfer around 8-bit, 1000-bit, too many bits doesn't matter. That's why in your telephone at your house, the wire go into your telephone, only one wire. They need serial. Okay? However, the difference for parallel data, inside your computer, they must be parallel, not serial. If you buy the computer, they can asking you how many bits. Okay, you can say 16 bit, 32 bit, or 64 bit. Now, if you get a 16 bit, that means they only transfer 16 data. Okay, 8 bit will be for 1. Okay, so you need 16 wire. 32 bit, you need 32 wire. 1 wire for 1 bit. So that's why outside you cannot transfer data by parallel. No, don't have a room enough for too many bits. Okay, so anything transfer data outside, they will be serial. However, when they go into the computer, CPU don't know how to deal with the serial. So that's why they need the IC to converting serial to parallel. Now, if you're looking on this IC here, you get 14 pins, okay? Pin 7, ground, 14, 5 volt. Now, you get input, serial input A and B. Pin 1A, pin 2B. And then you get the output, 8 output. QA, QB, QC, QD. Okay? Q, E, F, G, F, that's the 8 output. Also, you get the input clear, active low. That means if clear equals 0, all of the output must be 0. And also you get a clock signal. A clock will be help to loading data from serial into the output. Okay, now you're looking in the truth table here. Clear 0, active low. Then the clock you don't care. A, you don't care. Input A, input B, don't care. Output must be low. Clear, override everything. Every time clear 0. You cannot do anything with the clock or input A, B. Output must be 0. When the clear high, see what happened? Clock low. Okay? And input, you don't care A and B. Output QA 0. How much you understand what the output here? What that mean?
No change. Stays the same as before.
Exactly. When the in clock is 0, no clock, then they don't care A and B. Output whatever it was now will be the same. Okay? It was 1 0 1 0 1 0 1 0. Now still be 1 0 1 0 1 0. Okay? Be the same. When the clock going from 0 to 1 transition, okay? If input high, then the first high will be go to QA, and QB will be shifted going down, okay? And also when the input A low, okay, then you get the clock. QA now will be low. That means the A, B here, shift it into the QA. And whatever QA will be shifted down. Okay, so that's how they working. Let's see what else we can get in here. Okay, we don't care that.
So,
Let's see
Mr.
next
Pham,
step. Yeah,
so does that mean when we have the clock going up, and when whether it is A,
whatever in AB.
whatever AB, if it's low, then it will
No
go
low
low.
here.
Okay, so it can be low A and B both both low, then everything will be low for all the output.
No. If A and B low, right?
A and B both are low. What happened there?
You say what A and B equal?
A is low, B is low.
No,
You cannot have that?
no. Normally, they can using, if you want to do that, you can using that one here. Okay, A low,
Mm-hmm.
you get a clock, QA low.
Right. Or you can use B low and you still get low and
Yeah.
lower.
But
you can,
normally the way they design, if they using one serial data going in, A and B tied together. The thing is, what happened inside this IC, A and B end together. So if you're using only A, B, you must set it to logical 1. Otherwise, data cannot go. But the way design A will be tied to B if you get only one input series coming in. Okay? So at the clock, input AB will be shipped into QA, and whatever at QA will be shipped to QB. Whatever at the QB, ship it out, keep ship it out. Okay, that's how that IC working. The next lab you will be working on this one. Okay, so we're done with this, and now here we can get another one. Okay, let's see. Okay, that one also given to you decoder for 139. We already done it. Okay. Now, next one, 138 here. So now if you're looking on that one, they given you a IC, okay? And also that is how they working. We already done on that. Now, next one. That I see here. Okay, let's see. That will be transparent. 3-state output octal. D type flip-flop with 3-state output. So if you're looking on this IC, you get total 20 pins, okay? 20 will be 5 volt, 10 will be ground, okay? And now if you're looking into here, basically inside they just get the DLAB, okay? You get input, you get the input, let's see, how many D? D2, okay, D1,
There's 8.
D2, D3, okay, D4, D5, D6, D7, okay? That means they get 8 input and 8 output. You can see Q0, D0, Q7. Okay, now see how they working. Just a DLAB. Normally DLAB you can get, we are done in the past, you get only 1 bit, 1 Q. However, normally computer they're using 8 bit. Okay, so that's why they have to make the IC cover for 8 bit. If you 16 bit, they need 2 IC. Okay, and so on. Now, only the DLAB, then input output will be the same. First thing, DN. Okay, let's see what the DN here. And LE. LE, what pin in here? LE pin 11. Okay,
LE is latch enable,
yeah, latch enable.
and OE is output enable.
Okay, ON here, pin number 1. Output enable.
No, that's, yeah, OE is output enable, yeah.
Okay, D input, that means that's the input here, that is the output here. Okay, now, first thing, if you get the data at the input, you get the, I say, old one day. 1, 1, 1, 1, 1, 1, 1, old one. Okay, first thing, if you want, you apply the input on 1, okay, to the D input here. If you want it to go into inside this IC, then LE must be 1. Okay, LE must be 1. So 1 will be go inside. Okay, but they go inside here. They not go into the output until output enable pin 1 is 0. Pin 1 0, then whatever inside this IC will be go to the output. Okay, and now what happened in LE? LE is low, okay, and the output enable also low. That means LE low here, and this one still enable. What happened?
No change.
LE low. Any input at the data input here cannot go inside the IC. Okay, so summarize. You apply input data D. If you want to go inside this IC, then you have to apply LE equal to 1. And if you want the input inside here appear at the Q output, then OE must be 0. Okay? In the KLE at the logic 0, you can change the input data here, but they cannot go inside this IC. That's how this IC working. And the next one here, very simple, same thing like the other one.
Hey, Mr. Pham,
74, 374. The last, however, the difference will be the clock signal. Okay? That means the input only go inside this IC. When you apply the input data, you need the clock going 0 to 1. Then they go to inside. However, they not go outside until the output enable. Okay? In here, what output enable? Pin number. Output control, pin number 1. Okay? Pin number 1 active low. That means you get a 0 here. What input inside this flip-flop here will be going out. Okay, you can see they get the SD flip-flop. 1, 2, 3, 4, 5, 6, 7, 8. SD flip-flop. Okay, you put in one IC. So that's why they can save the room. Instead, you have to build one at a time, take a lot of room. Okay, so now this for 8-bit, you want 16-bit, you need 2 IC. Okay, and 32-bit, you need 4 IC. That's how inside the computer working. Okay, the last one. Octo bus transceiver 245. Okay, now you can see on this one also 8-bit, remember. Okay, 8-bit on both sides. So this is bi-directional. That means data can go from here to pin number 18, or they can go from here to number 18 to number 2. That means they can be both in or both out. They can go bi-directional. Okay, they just like a buffer. They cannot change anything. If you get a one input coming in, they can go into pin 2, okay, 1. Or you get a pin 2, 0, then they can go into pin 18, 0. Okay, they go both ways. That's what they call a bi-directional.
And the
Okay.
direction is controlled by pin 1 and pin 19.
Controlled by pin 1. Okay, first thing. Pin 1 means DIR means direction. You want to go this way, or you want to go this way. Then you set pin 1. Pin 1 is 1, they go this way. Go this way. 0, they go the other way. Okay, that's what they're talking about, directional. Direction. And pin 18 means enable. If pin 18 at a logic 1, look like this IC completely disabled. Okay?
pin 19 is enabled, 19.
Yeah. If you want it working, either data can go from A to B or B to A, then pin number 19 must be 0. If you set pin number 19 at logic 1, look like this IC not inside the circuitry, they will be high impeded. You're not loading the data in the bus. You see that the way they build, they try to build 8-bit, okay? So depending on inside your computer, how many bit, they using one IC or they using two or four, okay? And so on. And this will be given you data input here. Enable low. Direction equal 0, then data from B to A. Enable low. Direction high. Data will go from A to B. That means 8-bit they can using both direction. Okay. And enable high isolation. Okay. That means look like this IC not inside the bus. So they're not loading any current down. Okay, that's all of the IC will be need for your lab in the future. Okay, now I will be go to you on the DLAB number 6. Okay, DLAB number 6 here. They're using IC 160. 160 means BCD counter. BCD, you understand? BCD will be binary code decimal. That means binary, they're working like the decimal. And you understand the decimal get only number 0 to 9. Okay? So that's why input A, B, C, D here, you can loading any data from 0 to 9 only. For example, number 9 will be 1, 0, 0, 1, number 9. You don't have any number greater than 9 for this IC. Okay? The thing is this IC, normally they converting into the input binary, okay, and to the output binary, but only BCD. And this IC can have how many functions? They get the input clear, active, low. That means if the clear equal 0, output here must be 0, no matter what. Okay? And also you get the input for the loading. That means you can loading data A, B, C, D to the output QA, QB, QC, QD, any number. You apply 1, 0, 0, 1 means number 9. If you apply pin 9, 0, then output will be 1, 0, 0, 1. However, pin clear must be 1. In this IC, clear will be a higher priority. Clear equal 1. No matter what else here, don't care. Output must be 0. Okay? Pin 1 at a logic 0. Output here must be 0. You don't care here. When I said you don't care mean what? If you apply input 1, pin 1, 0, output is not 0, then you just make sure to get the power, then the IC not working. But you don't telling me you have to measure pin 9 or pin 10. No. The thing that we say we don't care. Don't care mean never take any measurement. The thing is don't care, they can be either 1 or 0. So you don't know which one you want it. How come you measure? Okay. However, if you want to loading number 9, 1, 0, 1, 0, 1, number 9. You apply clear must be logic 1. Pin 9, load must be 0. Then you read the output here have to be 1, 0, 0, 1. If it's not, okay, then you can troubleshoot this way. First thing, when you get QA, QB, QC, QD, if you see which one is wrong. For example, A, you apply 1, QA, you supposed to be 1, okay? But they not 1. Then you have to measure at pin A to see you get 1 or not. If you get 1 in here, and they not 1 at QA, what next can you tell me you want to do?
Replace the IC.
No, not yet.
Uh-huh.
I said again.
Oh, well, I guess you can go back to pin 18 of U1A and check to make sure you have a 1 there.
Yeah, that's what I say now. Okay, don't worry about that one, okay? I'm talking right here.
No, but if you have,
No, I don't talking about this part here.
that's not what I was talking about either.
Well, I know
U1A?
you're talking about this one. But
No?
I don't, I right now, I isolate down to this IC only.
Oh, okay.
Okay, now, when you loading, okay, now, you're loading number 9. So you apply 1, 0, 0, 1. You apply load
Oh.
0.
Then you want to make sure that clear is at 1 and load is at 0.
Perfect. Okay, you know how to do. So basically, when you run, the output will be 1, 0, 0, 1. Now, you see it failed. Then you take QA for 1. If you get the QA not 1, then first thing you go back to A. That A is supposed to go QA. Make sure you get the 1 here. Okay? If in 3 QA you get a 1, output QA pin 14 not 1. You need to make sure pin number 9 must be 0. And pin number 1 have to be high. Okay. Now, if you get that, normally you found the problem. You say U2 is not working. Then you have to change U2. Okay? You not try to keep doing. Normally, the way for testing when the test fail, you must be stopped. Don't try to run anymore. You have to fix that. Then run again. The thing is one fail can cause another fail. Okay, that is the way how to test it. Now,
Hey, Mr. Pham,
Yeah.
what if there was a clock problem? What if there was a clock problem?
no, the thing is when you're loading, you don't care the clock.
No, I'm asking you, what if you have a situation where you have a clock problem?
Okay, when we go up to there, I tell you. Okay, that is talking about load.
Right.
That should
Okay.
only affect when you're counting, though.
Yeah,
Right.
when you clock, that means when you start counting.
Right.
Okay, now this IC will be counting 0 to 9, then 0. That's the only thing we can do. Okay, so the first thing when you want to counting, first thing you make sure on the output here have to be 0, right?
Right.
That means you have to clear. Make sure they 0. Then you have to unclear. Set it to 0, then set it to be what? Output 0 now.
Mr. Pham, couldn't you preset that to be any number and count from that point?
Same thing. Yeah,
Okay.
you can loading number 5, count up 6, 7. No big deal. But they not count out. Okay, now counting. First thing, you have to make sure 0. Pin 1 must be 1. Pin 9 must be 1. You don't want to load. Then only thing you need to do is apply the clock. Then the output will be count to number 1, number 2. One clock count one number. So you get 10 clock. Okay? So when you get a problem, they not counting. That means you apply the clock, output still be 0. Then for troubleshooting, make sure pin 1 must be 1. Pin 5 must be 1. Okay, pin enable here must be 1. Okay, then enable, both pin have to be 1. And pin 2, the clock, you have to get the clock going from 0 to 1. If you measure right now the 0, the clock transition already done. So how do we check the clock in our system?
Oscilloscope.
There, you can connect pin 2 clock going to the scope. And inside the program, you make a loop to keep it running. You measure here, you can see square wave. That means you get a clock. If it's not, you don't. Okay? In case you cannot change software and you want to take the clock here, now you still have to using the oscilloscope. However, that will be a stored oscilloscope. That means that when they going from 0 to 1, scope can catch it and keep it for you. Okay, we get the scope at the school that is stored. And normally, when you want to do it, you can try to make sure you know how to using oscilloscope to store the data. That's really neat for troubleshooting in the computer. The thing in computer is runtime. They keep running forever. Okay, so that will be for U2. U1, we already know. U44. 20 pins. Pin 1, control input A1 to output Y1. Pin 19, control pin input, okay, 11, 13, 15 to 9753. That means this IC, they can separately to 8 bit, okay? If pin 1, 0, whatever on pin 2 will be go to pin 18, 4 go to 16, and so on. Same thing on this guy. Pin 19, 0. Whatever 11 input here go to 9, and so on. Okay? If you measure the output, pin 9, you get a 0. And you measure the input 11, you get a 1. They're supposed to be go to here, but they not. Then you must make sure pin 19 must be round. If pin 19 round, you get a logic 1, 11. You not get pin 9 at logic 1, Gen IC. That's it. When you Gen IC, you have to prove why. Okay? You can say, okay, I measure at pin 17, I get logic 1. But pin 5, pin 3, I'm not get logic 1. I take 19, the 0. So this IC need to be checked. That's it.
Hey, Mr. Fan,
So now the last one here. U3, you know 74, 74, right? D flip-flop. My question is, For the D flip-flop, you connect NOT Q back to input D. How did flip-flop working?
Is that some type of toggle or something?
Exactly. If you're looking back into the handout, I'm already telling you, for the D flip-flop, if NOT Q connect to the input D, now they working just like JK flip-flop toggle only. That means if the output 0, you apply the clock toggle, they go 1. If they 1, apply the clock, they go 0. Okay, that means toggle. Now, RCO. RCO means that is the carry output. Okay, that means when you go counting from 0 to 9, see what happened. I show you here. You see that one. You're able to get everything you want. Okay, carry right here. RCO. When they go, normally they 0. When they go high,
That's your clock pulse right there.
carry me. When it going high,
When you go from 9 back to 0.
exactly. When output go 1, 0, 0, 1, then they go 9. Go to 1. They go to 1, telling you they already reached number 9. Okay, and they go back to 0. So by looking at the output here, I know, okay, the counter already reached 1 cycle, 0 up to 9, and now go back to 0. Okay, however, on the output here, when they go high, then you know they already reached number 9 here. Then they go to 0. You cannot measure it. If you're using the oscilloscope with the started, you connect into pin number 15, then you can see the pulse coming up here and going down. The thing is started, they catch it, they keep for you. However, that will be a manual intervention. What that mean? That means you have to connect this output to the oscilloscope and watch it. Okay. However, we want to do it automatically. That means I'm using the computer to telling me is it they get a pulse coming out or not. So I connect it into the clock of U3A. Okay. So the first thing is when you try to clear, when you clear right here, apply 0, then output pin 5, they will be 0. Okay. Now, when this count up to number 9, you get the 0 go to 1 here. That will the clock will be clock the U3A. The output will be toggle. And I read the output 1, I know this is okay. If I reading the output still be 0, that's telling me no pulse coming out here. Okay? That the whole circuitry work that way.
Mr.
So,
Pham, I have a quick question.
yeah, go ahead.
And this might be a stupid question, but for U2, pin 2 is our positive clock, but doesn't the bubble designate it as a negative clock?
We're using P clock. That is a P clock. The thing is that from manufacturer for this IC, they put a wrong clock.
Okay, so that is incorrect technically.
Yeah.
Okay, thank you.
Yeah, the thing is different manufacturer, different like Motorola, Texas Instrument. Okay, too many company make the IC.
Oh,
So
do some work on a negative and some work on a positive?
yeah, that's what you have to look in here.
Depends on the manufacturer.
Yeah.
Okay.
So looking here, okay, you see the clock here, right? 0 to 1. Okay. That means the clock will be 0 to 1, not 1 to 0.
Okay.
Okay? By looking into that. The thing is when they start building, they follow upline negative clock, they not working. They're asking me, I say, look into the timing here. The clock have to be 0 to 1. Okay? That the manufacturer get the wrong one.
So the bubble don't belong there.
Yeah, exactly. Okay, now what you need to do is try to get this part. Okay? Here, first thing you need to make it part, right? So they say, I want to load. What data I supposed to put in here? Okay? You see, 1 clear. You have to be 1. Load enable 0, 0. Load have to be 0. Okay? So you can get the input A, B, C, D, load number 5. If you want load number 9, same thing. By the way, for this IC, clock control everything. You want to clear, then also you need to apply the clock. They will be clear. Okay? You want to load, you also have to apply the clock. They will be load. So the clock control everything on this IC. Okay? So this is clear here. You see, input here, clear here, 0, 0,
So-
0, 1.
In this case, then clear would be synchronous with the clock,
Right,
not an asynchronous.
right, synchronous. All right, load synchronous. That means the clock control everything. No matter what you want to do, by looking into here. See that? You want whatever, to clear or load or whatever, they must be get a clock. Without the clock, they're not working. Okay? So this one, when you're looking back into the record video, that will be helping you to get it part. Okay? And now you have to get a port A, port B, port C. Okay? So if you want to load this number, what that number is supposed to be. Okay? And when I said not able, that means for the TET4 or TET5, TET number 15, you don't have to write to port A. You write to port A only on TET1, TET2, TET3. Okay? However,
The clock for everything.
yeah, you have to write twice. Okay? You write to port A, first thing. Then now you have to write to port D. So in your program, okay, first thing you said write to port A 0x05, okay, and write to port D 0x01. Okay, then you have to apply the clock, right? That is test number 1. Then when you're going down, okay, for test load 0101, so you want it to be 0101, 0x05. However, math data, this is the U3Q, you're not testing now, you don't care. So the math data will be 0F. And something wrong, they will be U1 and U2 only. Okay? That means U1 is the buffer, U2 is the counter. And that number 2, you still don't care on this one. You apply load number 9, you get number 9. In here, I'm not let you writing here. That means I still keep math data 0x0F and the P corp still U1 and U2. Now, you test the clear U2 and U3. So that means I1 output U3 must be 0 and the red here 0. So output you reading 0, however, the math different. The math now you have to math for this guy. So that's why 1F. And anything wrong will be happen to U2 and U3. Okay? And now you start counting up that number 5. Okay? Whatever you have to write to port A, port B, port D. Then that number 5 count up, you get number 1. The math data now going back to 0F. You don't care this guy. P-cop, now they not count. Only U2. So this is not changing. Okay? The thing is, P math data keep the same. P-cop keep the same. Only when you get the last one. Okay? U3 toggle. That means on the last one, U1, U3Q must be 0. Now they must be 1. Okay, so the math data only 0, 1, 0. You don't care what happened to this guy. Okay, output here, we don't care. I care really they go to 1 or not. And the P-cop will be either U2 or U3. Okay, that means telling you either this guy not sending out the points or this guy not toggle. Okay, so P-cop only U2, U3. Okay, the way testing is the first two tests, we test this guy U1A, U1B. After the first two tests, nothing wrong with that guy, U1A, U1B. Now can be wrong either U2 or U3, depend what you want to test. Okay, so also in the program, I already given you the loop to do the test. Okay, you see that whatever here. Okay, but I given you the loop here. Let's see. Oh no, I don't have a loop for you here. So you have to write the loop. Okay. Now, any question? Everything I already given you. Everything. How
Mr.
come
Fan.
you not do it? Yeah.
Quick question, if you could explain really quickly, you said for test number 3, load 0010, that the peacock is only U2?
What that number?
Test number 3.
Yeah, that only U2. The thing is U1, U1A, U1B. Something wrong. They must fail that one or must fail that 2. You understand in the digital system, how do we test? For any input output, you must test at the logic 0, then at the logic 1.
Hey, Mr. Pham, if I could just interject real quick.
Yeah.
That's why in most of these programs, you using 5.5 or AA or 0.5 or 0A because you're testing each bit for 1 and 0, correct?
Okay, why we using 0, 1, 0, 1? Then we're using 1, 0, 1, 0. Why? Why they have to test that way? I basically
You're checking each bit.
You need to test both for high and low at each pin and make sure that each pin is not grounded to the pin directly next to it.
Exactly. That's what the engineering we do it.
So my quick question here, Mr. Pham.
Yeah.
In this DLAB, our first test is 0101. Our second test is 1001. And it's not until our third test that input B actually gets tested as a 1. The first two tests, input B is a 0 both times. So in that case, have we not tested pin or input B for both a high and a low until the third test?
Now, if you look in here, now, if you look in here, for that, did 0. Next day 1, okay, right?
Yes.
And the next test did 1, did 0, that be 5. Okay.
Yeah.
Then the third one, 0, 0, 0 here, but they have to 1 here. That means every pin, they must be 0 and 1. They can be more 0, doesn't matter.
Right. But so if, let's say for test 3, your output results that you get is 0, 0, 0, 0,
No.
couldn't there be a problem with U1?
Yeah, the thing is right now you can see, that means if you say 0, 0, right?
If it was all zeros.
That means pin number 3, you not test for 1.
Right, that's what I'm saying. So
So
can't,
that's
so
why
should,
I have to test 0, 0, 1, 0.
right, but so because of that, shouldn't the peakoff for test 3 also be U1 and U2, not just U2?
No, they take over U1 already here.
Hey, Mr. Pham, I think what he's saying is
Okay, I can see. On that data here, you get 0, 1, 0, 1, right?
Right.
Okay, and then you get data for number 9 here. Okay, only thing is, what I want is the data will be cover 1 on X1. So you see which one is missing.
how come you didn't use, you used 5 as a load?
No,
How
the
come
thing
you-
is, this guy cannot working on 5. 9, 8. They go on the 0 to 9.
Oh, that's right. So you can't use
Yeah,
a 1010 because that's
Okay.
10.
yeah. But the purpose is we guarantee each pin must be tested for 1, then 0. Okay? So in here, the first one I test 0. Second one, 1. So maybe need to adding another test.
I just don't understand why test 3, the peakoff is only U2 and why it doesn't include U1 as well. Because we haven't, up until test 3, we have not tested that pin for a 1. So it could still be a faulty U1 causing the issue, could it not?
Perfect. You're very good.
I think test 3 is peakoff is U1 and U2.
He was just saying it was U2 only,
Yeah.
so I was confused.
Yeah.
Yeah. It should be U1 and U2.
But
Right.
the thing, yeah, I understand. But the
Okay.
thing is, my purpose, that's very good. Okay, my
Okay, so
purpose is,
okay. Thank you.
You're doing very good. My purpose is, I want to test X output to be 1 and 0, right?
Right.
So I have to thinking about that 1, but that doesn't matter. Okay, will be modified, for later on.
In other words, as I believe it was Adam who was saying that, you need to add like one more test, you're saying?
Right.
So
Somehow,
instead of having 3 loads, you would have 4 loads?
exactly.
Okay.
That's easy. Okay, but bring it up that problem. Very good. Okay. So
All right, Adam, you get your certificate.
for sure. The thing, I'm talking to your guy. I know how much you understand. So that's why I want to keep someone still in the program with me. Any question? You don't have to be in the Zoom, but you must be uploading all of the requirement. That is the one I prove for the city. How come I gave a certificate for you? You must be understand that my situation. So when we done, someone gets certificate, someone not, don't call me. I need answer. You know what you're doing. I know what I'm doing. Okay, any question? Otherwise, we'll be done.
All right, thank you, Mr. Pham.
Thank you very much. And Mr. Pham, to be clear, the DLAB08 that is currently uploaded to the website, should we just ignore that for now?
Ignore that for now.
Okay, thank you.
I will change that to different lab very soon. Okay?
Okay, so you got
Thank
to do
you.
an update, right, Mr. Pham?
Yeah, maybe after tomorrow.
Okay, so don't do it for right now, and Kumi don't have to worry about it.
It's actually the DLAB06 that we already did. So if you did that, you already did it.
The thing is, just I not done for 4 or 5 or 6. I said just 7. Just see me. Okay? Just about 30 minutes, you can get everything done.
Hey, Mr. Pham, I've been with you for a few years, so I know you used to go all the way up to like DLAB 20, right?
Yeah, but now we go up maximum 30.
Oh, okay.
The thing is, we given too much and they get nothing. Then what? What we want? I want to slow it down. And now I put all the fam to control, report to me so I can understand who done, who not done.
Hey, Adam, what if we had to do DLAB 20?
No.
Man,
And you understand
I'm gonna run away.
understand the fall. Will be go back to the class. So you want to get certificate during that fall. Then you have to show me you already done here. Okay. On that time, you just doing the lab. That take you very short time. Okay. To get the certificate. And then and that time I just deal with the people. Do your homework. Okay. Your take you now, I not allow you, not forcing you to do assignment for take one. The thing is last semester I did okay for take one. Okay, then you don't have to. But that requirement, I need the DLAB program. I need the quiz and I need the e-calculation. Okay,
Okay.
see you guys next week.
All right, Mr. Pham, thanks a lot.
Good night.
Thank
Good night.
you.
Good night.
Good night.
you.
Thank you.